道全台北最帅的男生在哪里吗？在台大。孩子们，老大现在要去1巴上吃午餐了，跟我来吧。
Hello everyone. For our final project of transportation engineering, we decided to conduct a safety and efficiency inspection on the NTU Sinhai main gate. As you can see, the NTU Sinhai main gate serves as a critical access point between the main campus and IPA, a popular lane for students and pedestrians alike. Our objective is to identify the geometric and operational deficiencies that exist in NTU Sinhai main gate. Through site observation, we identified 3 critical issues: directional confusion in the bicycle network, dangerous conflict points with motorcycles, and insufficient capacity for pedestrian flow. Following deeper on the bicycle problem, usually riders are expected to ride on the right side of the road, but for some reason the current design has the ingress bicycle lane on the left side. This is a problem because it is a counterintuitive design that forces bicycles to often go onto the other cyclists or go against the current flow of traffic. The second problem, as mentioned before, is the motorcycle turning point. As you can see, this is a critical turning point that goes into the NTU library underground basement. But because this is a high-speed entry point, motorcycles often turn without using or giving way to pedestrians or cyclists. This may cause collisions or site obstructions between road users, causing accidents or collisions to be more frequent. Finally, the last problem, pedestrian spillover. During peak hours, this pedestrian road usually doesn't have the capacity to fill the amount of people going in and out of IPA. This causes them to spill over and overtake the bicycle lane. What happens is that when they overtake the bicycle lane, it reduces the effective width and space that cyclists can use. This often causes them to go into the vehicle lane, and even sometimes both pedestrians and cyclists just use the same road altogether. This can cause collision and increase risk of accidents. To validate these issues, we conducted a field survey during peak hours. As seen in this footage, the violation rate of lane discipline is high, not necessarily due to user negligence, but due to poor geometric design. The friction between the 3 modes of transport, pedestrians, cyclists, and motorcycles, is evident here. The infrastructure does not support the actual demand.
孩子们，老大好像摔车了，腿好像断了。这个路口设计真的是。
Based on these findings, we propose a new design to realign the infrastructure with standard traffic engineering principles. So our new proposed design is that these 2 correct bicycle lanes will later be extended and elongated. We will expand the road so that the bicycle lanes will be able to continue from that path to that path. This removes the usage of split lanes, so no more right path, no more left path for the bicycles. It will all just be one continuous straight path. The pedestrians will be able to walk from this path all the way to that path, and for the most part, their direction and walk flow won't be changed. Also, pedestrians coming from that way will intersect at this point, but that won't really be much of a problem since there isn't much traffic flow. The planned section here will be reduced to maybe half of its original size in order to give space for another bike lane here. As I mentioned before, the lane there will be congested into one bike path with 2 directions. This means that both cyclists going in and out of IPA will be in this path, achievable by cutting off the planned section by half. I've used analogic, which will be explained by my friend.
各位同学，大家好，今天就由我来讲解 AnyLogic 模型，让我们打开软体来看看吧。这个就是我们做出的模型。第一步，我们需要汇入 Google Map 的路口截图，并且调整大小，与模型中的比例相符合。第二步，我们就可以直接来开始画路。点击左边面板，道路交通库里面的路，双击2下，就可以开始把路画在我们的图面上，并且在连接的路段、交叉的路段会直接产生出一个路口。画好路之后，点击它，就可以调整它是否是单行道或是车道数量等等的资讯。第三步，我们就可以直接来做参数化设计。从左边的面板中找到 Car Source、Car Dispose、Car Move To， 以及 Select Output 5。 们可以把这些全部拉到我们的画面中。Part Source 点进去之后，我们可以在右上角选择我们需要的路段，并且定义到达的速率。Select Output 5可以让一台车辆做出5种选择，并且需要输入每个选择的几率，也就是说选择哪一条路走。或因为我们只有一个路口，所以只会用到3种，也就是直行、右转跟左转。Car Move To 点进去后，可以定义每个选择对应到的哪一条路上，最后让所有Car Move To 连接到 Car Dispose， 让车辆消失。最后，我们可以来添加一个红绿灯，在左边面板可以找到一个红绿灯，并且拉到我们的画面中。在右上角可以选择我们要的路口，再来就会出现一个表格，让我们调整每个路段可以行走的时间各是多少。都完成之后，我们的模型建模就完成了。接下来我们按左上角的绿色三角形就可以开始模拟。接下来我们看看现况模拟与我们修改之后的模拟情境是什么样吧。
In conclusion, the current layout at Xinhai Gate suffers from conflicting design logic and insufficient capacity for mixed traffic. By realigning the directional flow, segregating pedestrians, and structurally modifying the conflict points, we can significantly reduce the accident potential and improve the commute for all students. Thank you for listening. We are happy to answer any questions regarding our design proposal.